The last thing we want to take a look at as we're preparing for the final exam is reviewing the applications of integration. The first application that we looked at was finding the area between two curves. So let's say I want the area between y equals 12 minus x squared and y equals negative 4x. Now, if I think about the graphs of these, just kind of a rough sketch, I know 12 moves the graph up and the negative x squared flips it over. So it's going to look something like this. And negative 4x squared is going to have a slope of negative 4. It's going to look something like this. So we're looking for the area between that curve. And to find that, first we need to know where the graphs intersect, so I know the integration points. And then, remembering, we're going to take the top equation, 12 minus x squared, and subtract the bottom function, negative 4x. So first, to figure out where they intersect, we're going to take the two equations and set them equal to each other. 12 minus x squared equals negative 4x. If I set that equal to 0, we've got x squared minus 4x minus 12 equals 0. And that's going to factor to x minus 6 times x plus 2, which means x, my intersecting points, are at 6 and negative 2. So those are our intersecting x's. So now we're ready to set up our integral. And we're going to integrate from negative 2, which is the one on the left, up to 6, the one on the right. The top function is 12 minus x squared. And then we'll subtract the bottom function, which is a negative 4x, and making sure we distribute that all the way through as needed. This is what we want to solve to find the area between those two curves. Integrating, we get 12x minus x cubed times 1/3 plus x squared times 2 using our power rule. And then we're going to integrate that from negative 2 to 6. Plugging in what we know. The top number first, so we've got 12 times 6 minus 1/3 times 6 cubed plus 2 times 6 squared. Then we're going to subtract, and make sure we're careful. We have to subtract each term. So it's going to change the signs all the way through. Be careful with that. We've got 12 times negative 2. Then I'm subtracting a negative, which makes it plus 1/3 times negative 2 cubed. Subtracting a positive makes it minus 2 times negative 2 squared. Probably going to reach for my calculator to figure this out. When I plug this into my calculator, I'm coming up with 85.33 units squared is the area between those two curves. The second application we want to take a look at, and actually the next couple applications, all have to do with finance. So first, let's say a company invest $100 per month at 12% interest for 7 years. We want to know how much is going to be in the account at the end of this time. In order to figure out the total investment, we look at the continuous interest formula of PE to the RT, and we're going to integrate it from 0 to the total time with respect to the individual times. In this case, remember, the capital T stands for the total time. So yes, it's 7 years, but we have to also multiply by 12 because it's invested monthly. So we're going to have 84 total installments of money. R is the interest rate, which is 0.12, but we have to divide it by 12 because it's compounded monthly. So that we're actually gaining 0.01 every month. And P is the principal amount of $100 that's put in every month. Put that together, and we're integrating from 0 to 84 months. The principal of 100 times e to the 0.01t dt. We might solve this with a little u substitution, where u is equal to the 0.01t, because then the du is equal to 0.01. So we're going to do 1 over 0.01 times 0.01, so that we have 100 over 0.01, moving that 100 out because it's a constant, integral from 0 to 0.84. Remember, we need to plug in the 84 into the u equation. So 0.01 times 84 is 0.84. times e to the u du. And if I were to calculate the 100 divided by the 0.01, we end up with 10,000 e to the u integrated from 0 to 0.84. Plugging that in, 10,000 times e to the 0.84 minus e to the 0. And if I plug that in to my calculator, I end up with $13,163.67. So if we just want to take an annuity, monthly investment put away, we just have to integrate the PE to the RT equation. But sometimes we're interested more in present values and future values of investments. So let's say that we want to find the present value of an 8-year investment of $8,000 per year. So we've got a money stream that's bringing in $8,000 per year at 1% interest. If we want the present value of the investment, that's going to be the integral from 0 to the total time of the function, which is our money stream, times e to the negative rt dt. In our case, the present value is equal to the integral from 0 to the total time of 8 years. Our money stream is $8,000 per year. E to the negative 0.01 is our interest rate times our time dt. And we just need to integrate this function. Again, we might use a u substitution where u is 0.01t. How about negative 0.01t? du is then equal to negative 0.01 dt. So I'm going to multiply a 0.01 and divide by a 0.01, negative, so that the 0.01 dt comes out. So with the 8,000 being pulled out, we get negative 8,000 divided by 0.01 of the integral from 0 to negative 0.08 e to the u du. And since these limits of integration are actually backwards, I'm going to switch them and put the smaller one on the bottom. When you switch them, it's also going to change the sign on the integral. So we're going from negative 0.08 to 0, and now it's a positive out front. 8,000 divided by 0.01 is 800,000 times e to the u integrated from negative 0.08 to 0. So we have 800,000 times e to the 0 minus e to the negative 0.08. And then we go to our calculator. And that's going to give us $61,506.92. So I could invest $8,000 a year for 8 years at 1% interest, or I could just have $61,000 right now. They're both going to have the same value at the end of that time. That's our present value of the investment. If I want the future value of investment, let's do of a 7-year investment of $140,000. That's that continuous stream of income, compounded month, compounded continuously at 3.4%. Well, the future value formula is really similar. We're still going to integrate the money stream from 0 to t of e to the negative rt dt. The difference is we're also going to multiply out front e to the rt, capital T. And that gives us the future value of that investment. So our future value is equal to e to the r, which is 0.034, times time, which is 7 years, of the integral from 0 to the 7 years, of the money stream of $140,000 times e to the negative 0.034, the interest rate, times the t that we're integrating with respect to. So again, we're going to do a u substitution, where u is equal to negative 0.034t, which makes du equal to negative 0.034 dt. I'm going to pull the $440,000 out front. I'm also going to divide by negative 0.034 so that I can multiply by negative 0.034. So we have that in there for the dt. Putting that all together, nothing's going to really simplify nicely out front, so I'm just going to write it all down. We've got 140,000 e to the, I'll multiply out 0.034 times 7 is 0.238 over the 0.034. And then we're going to integrate from 0 to, again, I have to plug that 7 into the u equation. So I multiply 7 times the negative 0.034 to get negative 0.238 e to the u du. And again, my limits of integration are backwards, the small one's on the top and not on the bottom. So I'm going to switch them and make it positive overall. So we have negative 0.238 and 0. That way, when I integrate, we get 140,000 e to the 0.238 over 0.034 times e to the u integrated from negative 0.238 to 0, or 140,000 e to the 0.238 over 0.034 times e to the 0 minus e to the negative 0.238. Putting that into the calculator comes up to $1,106,449.62. That's going to be the future value of this investment. The last type of application that we took a look at was finding producer and consumer surplus. So for example, if I knew that the demand equation for a product was given by negative 0.01x squared plus 0.69x plus 410.4, and the supply equation was given by s of x equals 0.02x squared plus 2.22x minus 205.2. In order to find the producers and consumer surplus, we remember that we have the equation that the consumer surplus is equal to the integral from 0 to the equilibrium point of the demand equation minus the equilibrium price dx. And then, of course, the producer's surplus is equal to the integral from 0 to the equilibrium point of the equilibrium price minus the supply equation dx. Which means first we have to find that equilibrium point. The equilibrium point is when the supply and demand equal up with each other. So we're going to set the two equations equal to each other. The negative 0.01x squared plus 0.69x plus 410.4 is equal to the 0.02x squared plus 2.22x minus 205.2. We're going to make the equation equal to 0 by adding the 0.01 to both sides. When I do that, I'm going to get 0.03x squared plus 2.22x, subtract the 0.69x, and we'll end up with 1.53x minus, we've got the negative 205.2, and we're going to subtract the 410.4, and that's going to be 615.6. Lots of ways we can solve this. I'm going to go ahead and use the quadratic formula that x is equal to the opposite of b, negative 1.53, plus or minus the square root of b squared, 1.53 squared, minus 4 times A, which is 0.03, times C, which is negative 615.6. And because that's negative, I'm going to pull the negative all the way out, which is going to make that a plus, all over 2A, which is 2 times 0.03. And so if I plug that into my calculator, I probably don't care about the minus because I don't want a negative. So I'm just going to do the plus and put that into my calculator. When I put it in my calculator, the positive answer I get is that x is equal to 120. If x is equal to 120, I should be able to plug that into either the supply or demand equation to find the equilibrium price. I'm just going to plug it into the demand equation, and that's giving me an equilibrium price of $349.20. Now that we know the equilibrium information, we're ready to actually move on to our formulas to calculate the consumer surplus and the producer's surplus. Let's do the consumer surplus first, which is the integral from 0 to the equilibrium point of 120 items, of the demand equation, which is negative 0.01x squared plus 0.69x plus 410.4. And then we subtract the equilibrium price of 349.20 dx. Combining like terms at the end, we have negative 0.01x squared plus 0.69x plus 61.2 dx. We'll go ahead and integrate that by increasing the exponent by 1 and dividing by the new exponent. Gives us negative 0.01 divided by 3x cubed plus 0.69 divided by 2x squared plus 61.2x integrated from 0 to 120. If I plug 120 in, we get negative 0.01 over 3 times 120 cubed plus 0.69 over 2 times 120 squared plus 61.2 times 120. And then technically, we need to subtract what we get when we plug 0 into everything. But you'll notice that all of that's going to just be 0 times stuff and equals 0. So I just have to plug this into my calculator. That's going to give me a total consumer surplus of $6,552. Then let's go back and figure out the producer's surplus. I've got a little bit of space down here at the bottom. So let's partition this off. We've got the consumer surplus to the right. To the left, we found the equilibrium price. So now we're going to find the producer's surplus. The producer's surplus is the integral from 0 to the equilibrium quantity of 120 of the equilibrium price of 349.20 minus the entire supply curve, which means we have to multiply all of these terms by negative 1. That's going to change the sign. Be careful with the negatives. So we have negative 0.02x squared. Subtract a positive makes it negative 2.22x. Subtract a negative makes it positive 205.2 dx. Let's go ahead and combine like terms then. So we're taking the integral from 0 to 120. We've got a negative 0.02x squared minus 2.22x. And then we're going to be adding the 349.2 and the 205.2 to end up with 554.4 dx. I'll come over here for space. As we integrate that, we'll have negative 0.02 divided by 3x cubed minus, when I divide by 2, we get 1.11x squared plus 554.4x. And we're going to integrate that from 0 to 120. Plugging those values in, we get negative 0.02 over 3 times 120 cubed minus 1.11 times 120 squared plus 554.4 times 120. And then technically, we want to make sure we subtract off plugging the 0 in. But we know that's going to come out to just 0. So we can kind of cheat our way around that. And then we just have to plug this all into the calculator. And when I do, I get a value of $39,024 is our producer's surplus. Those are the applications that you want to be familiar with going into the final exam. It's your turn to start practicing these. There's a review assignment online. And then also good luck on the actual final exam.